Yeah? Cool. So today I'm just going to be talking to you guys about what raw sockets are, because they've kind of been more of a popular thing in the red team space, and I know a lot of people on the blue team have been hearing about it, but not exactly knowing maybe how to defend them or what exactly they are. So first, who am I? My name's Simon. I like to play paintball. I'm a member of CCDC, the red team. Thanks, Ian. I'm a member of CCDC, the red team. I feel like I'm on permanent black team for almost every competition we do. I'm into web security, application security, and exploit development, but I definitely like the first two a lot better. So anyway, just a little bit about me, but let's get into the good stuff here. So first, we're going to describe what a socket is, what exactly that looks like, how they're used, how it flows through a network and everything. And then we'll talk about what makes a socket raw in terms of a normal socket. And then we'll talk about why we use them, red team uses for them, and then we'll talk about what you can do as a blue team member to maybe find them, stop them, anything else. So first, let's talk about a normal socket. So just a quick disclaimer, this entire presentation is going to be geared towards the Unix side of things because I wrote my red team tool for just Unix, just the Linux operating systems. So Windows is a whole different beast. If you want to learn more about that, you can talk to Adriano, who's in the back row, or you can talk to Adler as well. He's not in here right now, but he's on Workplace. So anyway, what is a socket? So a socket provides a wonderful abstraction layer for you as the programmer to send and receive data either to programs on the same machine or across the network to a different thing, okay? So they make everything really easy. You don't have to worry about any networking stuff. If you've done this before in coding, you know that it's basically just open socket, send, write, receive, and then boom, you have all your data. You don't have to parse any of the IP layers. You don't have to parse any of the packet layers. It just does it all for you. Now, specifically to Unix, a socket will get what's called a file descriptor. And you may have heard the phrase, everything in Linux is a file. This is the same for sockets. You get a file descriptor, and then you can reference that file descriptor in functions like read and write. You actually have to pass it a file descriptor, and then it'll do operations on that file descriptor, in this case, the socket. So again, they make it super easy for you as the programmer. So let's just look a little bit at what the socket flow looks like. So this right here is kind of what an HTTP request would look like. So on the left side, you have your server. First, you have to make a socket, bind it to the interface, and then you have to listen. If you don't listen, you're not going to get anything. And then right here, the client's going to do the same thing, except the client doesn't need to bind or listen, because obviously the client's main concern is sending first and then receiving anything back from the server. So you're going to connect, and then once you connect, the server accepts you, hopefully. Client sends data. The server just receives the data. Server then sends back the reply. The client receives the reply, and then they close. They close the connection. All right? That right there would just be like a single GET request to a website. Establish a TCP connection. Client sends the request. Server sends the response, and you tear down the connection. Okay? So it's really, really quite simple and everything. And down there, Python sockets will cause you pain and suffering because they do really weird things, especially whenever you combine Python sockets with threading. If you're in the web class with Heim, you'll learn about Python sockets really fast. But they're great. It's a lot better than doing raw sockets. Does this make sense to everybody so far? We all on board with what a normal socket is? Any questions? I'm going to go with no. All right. So let's talk about what makes a socket of the raw variety. So with a normal socket, everything was abstracted from you. You just got the data. You sent the data and you received the data. Okay? Now a raw socket, none of that is done for you. You have to do all of that yourself as the programmer. Okay? That means you have to open each socket manually. That means you actually have to pass in values. And if you look at C code for this, they're macros. They're predefined macros for different values of different socket types. So if you actually start digging into the code, you can pass all these different parameters to make different sockets and read different things. So you have to open it. You have to build all your packet layers. So you have to build layer 2. You have to build layer 3. And you have to build layer 4. All right? So you have to build your MAC addresses, make sure they're oriented properly. You have to make sure your IP layer is all good to go. Your checksum has to be correct. Otherwise, no networking device will forward you. you'll just get dropped. You don't get rejected. You don't know why it got dropped. It just drops. That's a real big pain whenever you're debugging and testing. And then you have to make sure your protocol layer is good to go. So your TCP or UDP, whichever one you choose to use. And then once you get all that working, you have to marshal the packet. Marshal is just a term for, taking like structures and stuff and turning it into binary data. You marshal a JSON object, same kind of thing here. You just basically turn it into bytes because you send bytes over the wire. And then once you have your packet marshaled, awesome, you can yeet that thing over the wire. You're good to go. It just went to the server. But what happens whenever the server sends a response back to you? Yep, you also have to account for receiving it yourself. But whenever you receive it, instead of just receiving the data, your application is going to get the entire packet back. So you can't just be like, okay, payload or data from server equals received from socket, right? So if you're using normal sockets, you could do that because you know what you get back from the server from that socket is just the data. But whenever you're using raw sockets, it's going to be the entire packet and everything. So this is a lot of extra work. You have to do all the parsing and everything, but we're going to talk about why you would want to do this in just a little bit. So real quick, let's look at how raw socket kind of flows through the networking stack. So on the left, this is how a normal packet gets processed and interpreted by the networking stack in the kernel. So your NIC is going to receive the packet, and then you see it's going to go up the layers, boop, 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 right? And then back up to your application, which is the socket interface. For your raw socket, it's this right arrow, okay? You get hit with the Ethernet layer processing, and then it goes straight up to your application. All right, so then the kernel doesn't really do anything other than just the Ethernet processing. And most of the time, it won't even do much. It'll just be like, cool, is this for me? If yes, forward onto the application. Okay, so it doesn't do too much. So can anybody tell me what popular tool that you might use in a competition that sits at layer 3 at the IP processing layer? Yeah, what's up? Wireshark? Yeah, you could use Wireshark. Yeah? Firewalls? Yeah, so your firewalls sit at layer 3, right? So if you think about IP tables, whenever you do an IP tables thing, you're blocking on protocol or IP, right? Layer 3 or layer 4, okay? So that's why normal traffic gets stopped because it goes up through the stack and it gets processed by layer 3 and layer 4. So that's where IP tables are going to say, I'm dropping you, you're not getting by. Raw sockets, on the other hand, don't get processed by layer 3 and 4, okay? So this is one of the huge advantages of using raw sockets is because the firewall, at least on the host-based, okay? For right now, we're just talking about host-based firewalls. Raw sockets will just get around them. Okay, so you can have an IP tables rule to drop all traffic, deny any, and if a raw socket implant is on your box, they're still getting through. All right, they're still going to be able to communicate and receive from their command and control server no matter what you try to do, unless you find the application. Okay, so what is your firewall? It's useless now. Another reason it's really good to use raw sockets for is if you want to implement your own protocol. So since you have to build layers 2 through 4, right, you have all this control of everything. So if you just need layer 2 just for switching, so like if you're just doing something and it's just a network and you only want your packets to be switched around and you're not caring about routing, you could change layer 3 to fit your needs or make your own protocol. Similarly to layer 4, you could change things and make it not TCP or UDP and build your own protocol on top of it. Okay? So it's also a fantastic way if you really want to learn about network packet structure and how everything works and everything, because if you go through and actually have to code all of these steps and figure out how to make everything fit and work together, it's great. Whenever I was writing my tool to use raw sockets, I ran into a big problem with the checksums. You guys know that the IP layer has a checksum associated with it. If that checksum is incorrect or missing, any router just won't forward you, okay? That's the problem I was running into. So it's really cool. You get to find out a lot of weird things about cool stuff, but that's what makes it fun. So let's talk about raw sockets in terms of red team real quick. So again, bypassing your guys' host-based firewalls is a huge plus okay? It's really, really nice whenever like my buddy's implants or something, or they all go down, he's not getting anything, but all my stuff is still calling back because it doesn't rely on the firewall being up or down. However, the cons kind of outweigh, they don't outweigh the pros, but I could think of more cons than pros for this because the dev process is very tricky and it takes a long time. Another development process I ran into was using VMware to test this. So I'd have my C2 running on my host, and then I would put my bot on a VM, and then I would try to test things, and I'm like, cool, everything works. Raw sockets are working perfect. I'm good to go, ready for deployment. And then I start deploying on actual infrastructure, and nothing works. Now, the problem I realized eventually was that the way VMware works with communication is it actually, if you look at your interfaces on Linux, there's a shared interface for the VMnet. So like if you look, you have VMnet 1, VMnet 8, etc., right? So what was happening was the packet from the VM would hit that interface and just automatically be picked up by my host. So I wasn't actually sending the packet properly. I had some values that were flip-flopped in my headers. So that was a big pain and very, very sad whenever I realized my tool didn't actually work. Again, testing is a pain. My development process was basically git commit, git push, and then I would clone it onto the server that I was testing on. So it was a bunch of micro commits basically. There's a better way to do that obviously, but I was pretty lazy. Also, if you do something like making your own protocol, these things are very, very, very easy to see in Wireshark because Wireshark will do, you know how it makes the pretty colors? TCP is like purple, HTTP is green, whatever. If it picks up a protocol it doesn't know, it'll be like this disgusting gray line, or it'll do something really gross and it'll stick out because you're like, wow, that's not even a color, Wireshark. What are you doing? And it'll also say like unknown protocol or raw bytes. Wireshark will do its best, but it makes it very, very obvious as you're going through to be like, that's not right. Let's look at that a little closer. Now the problem is, even if you do see that, and if the data is encrypted or encoded in the payload, you might not know exactly what it is, or if it runs on a common port as well. Like let's say DNS, Wireshark will tell you that it's DNS, but if you have your program running on port 53 as well, Wireshark will recognize that that data is not DNS traffic, so it'll be like port 53, but it's unknown protocol. So that's also another big red flag. So, can Blue Team stop it? Let's talk about that one, because I've heard some things that Blue Team doesn't like the use of raw sockets, but they're really not that bad. It's just you have to think a little bit differently. So let's talk about Blue Team networking a little bit. So we got Red Team right in the middle. All right, big old angry react. Okay. Now those arrows are pointing to each one of your routers, and then you guys have your local area networks. Okay. So let's think about this for a minute. If the raw sockets only affect the host-based firewall rules, are they going to affect your router level rules? No, right? So if you do a deny any on your router, any traffic that's associated with the two raw socket bot and C2 will still get dropped, right? Because the bot isn't on the router, it's on the client. So basically the traffic just needs to get onto the LAN and then it'll pick it up. It's like putting Wireshark in promiscuous mode. That bot will see anything that goes by the computer, okay? So this is why we really, really stress networking defenses are super important, because you can deal with things without finding the implant. If you stop the traffic, Red Team can't do anything, okay? So your routers are super, super important, and they're one of the best defenses that you can have. So let's talk about the micro level now. So this is now on the host level. So we know that the raw sockets can get through, okay? But it's networking, so we should be able to see that somehow, right? We should be able to see that socket actually being made, the connection actually being made. That has to show up somewhere, right? So many of you probably know socket stat or SS, which is like the new net stat. You got the goto command here, which is tulpin. That'll show you TCP, UDP, listening connections. I don't know what P does. Oh, it'll associate the process with it. I don't know what A does. I don't really know what N does, but you throw it on there anyway, because it makes it look good, and I feel real bad if I forget one of those flags. So can we use this to find raw sockets? Well, Yeah, cool. Looks like it. This is straight from the man page. So it looks like we can add -w. So it'd be tulpan w as our full command. Display raw sockets. Awesome. So let's look. All right, there's a problem. There's no raw sockets. What the heck, man? All right, so you might notice the first 2 or 3 lines look a little weird, but upon further inspection, I really don't know what's going on in the first line. Couldn't tell you because the net ID is 3 question marks. I really don't know. But the second line is probably DHCP because it's on port 68, right? And then the third line is just some UDP thing to localhost. I don't know. But none of this is suspicious traffic. This is actually my normal machine. Like I wasn't running my bot or my server or anything on this, okay? This was completely normal, okay? So, and then I ran it again and it was the same output. I had to like sanity check myself for a second. Like, is this right? Question? 68? It's probably DHCP. What? I don't know. It's fine, because I thought the same thing. I was like, what is that? And then I closed it, stopped the program, and then restarted it. Yeah, I use RH. But you can use this other command called LSOF, okay? LSOF stands for list open files, okay? This command is awesome, not just for finding raw socket stuff, but it's awesome for anything in a competition because you can give it a process ID, and then this command will show you any open file that's associated with that process. So if you have a config that's constantly getting written over or something, you can LSOF and then grep for that config, and this will show you what process has that file open or what process is messing with that file. Super awesome command. So if we do sudo, you have to do sudo, because whenever I was making this, I forgot that, and I was like LSOF grep raw, and nothing showed up, and I was so confused. It took me like 15 minutes to figure out that I had to do sudo. So make sure you do sudo, but whenever you do it, look at that. CCDC bot's running, okay? That is the actual malicious program that's using raw sockets, and if you look, hang on, I almost destroyed the mic. If you look over here on the right side of the screen, you can see type sock raw, type sock raw, type sock raw. So those are all raw sockets being opened by that program, okay? So if you're on blue team, write that command down, and you can find stuff really, really easy, okay? And ladies and gentlemen, that means we got them. Thanks, guys. That's it.